Welcome to the project demonstration of underground cable fault identification along with location identification system by using PIC Microcontroller. So here we are going to identify the location wherever the underground cable fault identified based on the voltage drop. So as you know that the resistance is parallel to the length of the wire. So when we are passing when we are transferring the energy from one location to the another location. So this is a transmitting location RYB, and this is the receiving location at the receiver section. In our project, we are identifying the line-to-line fault. So whenever the line-to-line fault occurred, so there the voltage drops. That voltage drop is based on the length of the short circuit from the transmitting section to the receiving section. Considering, so this is a transmit section, receiving section. So from here, the fault is placed at the 10 kilo ohm resistance. So this is a 10 kilo ohm resistance, and this 20 kilo ohm and 30 kilo ohm. Totally 3 resistance. We can see that. So these 3 resistors are in series. Whenever the short circuit occurred, the respective voltage will be dropped based on the potential divider concept. So we have coded the microcontroller. Whenever the voltage drops, based on the voltage, proportionally the distance will be calculated. So if the 10 kilo ohm resistance was attached, then that based on that 10 kilo ohm and 20 kilo ohm, this potential divider ratio is 2:1. So the voltage drops at 2:1 voltage drop ratio. Based on that voltage drop, our microcontroller programmed in such a way that the fault occurred line to line fault. If this was short circuited, then the R and B, and this is going to be the R and Y, and this is Y and B, and this is going to be the B and R. So this is the short circuits of a line to line fault, and the voltage drops is based on the resistance. Just we are assuming the length of the wire considering 10 kilometers, and the resistance of the length of the wire is equal to 10 kilo ohms. Based on that, the voltage drops, and that will be measured by the PIC microcontroller from A0, A1, A2 pins, and the respective messages will be displayed on the LCD screen connected at the pin number B2 to B7, and for every fault detection, a buzzer will provide the audible alerts as a indication of the alerts. And as we are measuring the voltage of 5 volts in real time, as we know that phase to phase voltage is going to be the 440 volts, but our microcontroller can't measure the 440 volts AC signal. So for that purpose, we need to step down that with help of this transformer to the 12 volts of AC initially, and that is input to this regulated power supply board. It has 3 stages. First is rectifier to convert the AC to pulsating DC, and filter to remove the pulses, and regulator to provide the 5 volts DC constant output. So that 5 volts DC is input to the operating voltage of our microcontroller, and when we are providing the same 5 volts as the transmitting here. So if we get 440 volts here, then we will get the 5 volts here. So if there is any voltage drop over there, the same voltage drop occurred here also. So like that, we are going to converting the AC to DC with help of regulated power supply board. So let us see the demonstration. Just on the 230 volts input to that. Right. Initially, welcome message will be displayed, and thereafter, as of now, the status was normal. So if we are calculating the distance from the receiving section. So R and Y fault at 10 kilometer, Y and B and R. So if the two occur like here, B and this is B and R equal to 10 kilometers. Same for Y and B is 20 kilometers. Same for R and Y for 30 kilometers. Right, based on the voltage drop formulation, we are going to identify the fault, and we are using the line-to-line fault technology to identify that and alerting along with the distance calculation while transmitting the power through underground cables.